let's look at trying to find the limit of x plus 1 over x squared minus x minus 2 as x approaches negative 1. Now, there's multiple ways that we can find a limit. In this video, we're going to talk about direct substitution, graphing, and making a table. So the best one, I think, is trying to use direct substitution. Direct substitution just means take the number that we're interested in. I'm interested in as we approach 1, negative 1. So let's try to plug that number in. Well, if you guys were to try to plug in negative 1, we would run into a little issue because we see the factored form of this limit. In the denominator, we got x minus 2 times x plus 1. So if I plugged in a negative 1, we're dividing by 0. Bad news, can't do that. Function is undefined at negative 1. So by just plugging in the number, that doesn't really tell us anything. But if you notice, there's an x plus 1 in the numerator and 1 in the denominator. That means that we're going to have a removable discontinuity. Right? Removable discontinuity, remember that just means a hole. So just at that singular point, we're just taking that one away, and then we're going to continue on our merry way. Right? Think of a pothole in the road, right? You just skip over it. All right, now that we know it's a removable discontinuity, we can rewrite our limit as the limit of 1 over x minus 2 as x approaches negative 1. And that's something that we can plug negative 1 into, right? I can now use direct substitution, plug in negative 1, and the limit, excuse me, that does not equal negative 3. That equals negative 1/3. Classic mistake. Anyway, that's direct substitution. Love that. You can also utilize your calculator. I'm going to show you guys using a TI-84. Sorry, Casio users, have no way to help you. But what we got to do is we go to our y equals, make sure we're in our function mode, we plug in our function. Also note, both the numerator and the denominator are in parentheses. Got to watch out for order of operations. From here, if I want to graph, I like to go to zoom and then down to 0, zoom fit. Feel like it does it for you. And ba-bam. All right, if your function, if it doesn't really work, the zoom fit, you'll just have to go to your window and rearrange your values there. But we can clearly see that we have an infinite discontinuity in this graph, which is cool. So if we were interested in the point y equals or x equals 2, well, then we would clearly see that there's an infinite discontinuity there, and where when we're coming from the right, it's going up to infinity, but when we're coming from the left, it's going down to negative infinity, so the limit wouldn't exist there. But we're not interested in 2, we're interested in negative 1. So when we go over and we look at negative 1, using the graph, it's not really helpful. Right? I can see how the graph behaves. I can see that it does look like the limit at least exists right here, but we know when we plug in negative 1, we get an error and we can't really see what the exact value is. So graphs can be hit or miss, but now that we have the function typed in, we can go to a table. So to get there, we're going to go to second table, and here we got some x and y values. You can scroll up and down if you want to see different values. This is what it will autofill in your table. It'll go up by integer amounts. And when we look at negative 1, we see we have an error. And then we jump all the way to negative 2 and negative 0.5, right in 0 is negative 0.5. Those values are too far away for me to see how the function's behaving really, really close to negative 1. So since I want to know values even closer than that to negative 1, we're going to have to go to second table set. And then instead of auto, change to ask, enter. Now when we go back to our table, we'll be able to plug in values ourselves. So let's say I want to get really close, so I'm going to type in negative 0.01. And then I want to get, well, that's not close. negative 1.01. And we're getting even closer, negative 1.001. Right? When you type in -1, we know we should get an error. Perfect. Then let's see the other direction, negative 0.999. And then negative 0.99. Ta-da! And we can see as we get super, super close to -1, from both directions we're interested in here. So from this direction and this direction, we're approaching that negative 0.333. That's a really familiar decimal. Decimal, negative 1/3. So many different ways to find the limit, whatever way you prefer, really. But I'll show you some other strategies as we go forward.